Compute the sample standard deviation of the gas mileages of 20 passenger vehicles. So sample standard deviation has a slightly different letter because it's a statistic. It's from a sample, and we give it the letter S. The formula is actually different as well for sample standard deviation. Starts off the same. We have sum x squared minus sum of x in parentheses squared over n. The only difference in the two formulas is that for the sample standard deviation, and this is important to remember for the quiz and for the test, is we divide by n minus 1. And I don't have a great explanation for you for this. It's kind of technical. But I will say this. It should make sense that if we're estimating the standard deviation using a sample, we should have more variability. And because we're dividing by n minus 1, which is a smaller number than dividing by n, when you divide by less, the overall number, the overall standard deviation, is in fact more. So let's go through this calculation. It's actually quite similar, where we create a table using x and x squared. So let's carefully list all of our x's: 30, 27, 22, 25, 24, 25, 24, 15, 35, 35, 33, 52, 49, and I'm running out of space here, so I might just continue this, x and x squared off to the other side. 49, 10, 27, 18, 20, 23, 24, and 25. So in statistics, I get many students asking me, is it difficult? Well, I think really more or less it's the reading, as you might have seen in some of the homework. The math I don't think is terribly difficult, but it can be somewhat long. So what we're going to do is break out our calculator, and in a problem like this, software is nice to use, and we're going to square each one of the numbers. So let's do that, and you can take out your calculator. And for 30 squared, I get 900. And for 27 squared, I get 729. And for 22 squared, I get 484. 25 squared is 625. I just happen to know that one because I teach math. 24 squared is 576. 25 squared is another 625. 24 squared is another 576. 15 squared is 225. And 35 squared is 1225. And again another 1225. 33 squared is 1089. 52 squared, it's going to be much bigger, 2704. And 49 squared is 2401. 10 squared, 100. 27 squared, I know we did that before, 729. 18 squared is 324. 20 squared is 400. 23 squared is 529. 24 squared was, what again, 576. And finally 25 squared is 625. So as we did before, what we're going to do is add them all up and take our total from all of the x's and then from all of our x squareds. And again, the sum of all the x squared is important. The second column always goes first, and then the first column is always second. And let's carefully add those up. You can pause the video if you'd like, and I will add them up as well. and I get a sum of x of 543 and a sum of x squared of 16,667. So let's carefully plug these in to our sample standard deviation formula and see that the calculation is actually quite similar. So sum x squared from the second column, 16,667, minus the sum from the first column, 543, and that's squared, and we divide by the number of data. The number of data here were 20 gas mileages, and the whole thing is divided by, and here's where again it's different, not 20 but 20 minus 1, 19. Now if you're good on all this, then the main part that you want to focus on from here is just the calculator entry. What I do and I recommend for your exam is to do this part first and write everything down again. The more you write down, the more you're able to see, and the more I'm able to see and give partial credit if there is an issue. So let's do 543 times itself. And let's divide that by 20. And I come up with 14,742.45. All that is going to be divided by 19. And so next, no harm in writing it out. Let me do my subtractions. Subtract 16,667 minus 14,000. And I come up with 1,924.55. I divide that by 19. And I don't want to really round until I'm at the very last step. So let me keep my numbers exactly as they are and divide by 19. And I come up with a square root of 101.29 approximately, and I'm going to round to my second decimal place right here. And I don't want to round any more than that because I still have to take the square root. Upon doing my square root, I get my final answer. And I'm going to round to the nearest whole number because my data is given in whole numbers, and that's going to be 10. So my sample standard deviation is approximately 10